Top of the morning to you, physical geology students. Where this is the last video for this week. Okay, this is the last video for this week, and it's summer 42. We're winding down. You have this will be Monday. You're going to get more lectures, and you have a topographic maps lab to do this week, and you will have you'll have a final exam next Wednesday. So you also get a lab quiz on Monday, and then we'll be done. But anyway, here we go. This is from chapter number 11. We've already talked about rivers a lot, but we haven't started with groundwater. So groundwater is water that's underground. And one of the things you want to bear in mind is that there's 30 to 50 times more water underground than there is in all of the rivers and lakes combined. Therefore, our future is dependent upon groundwater. We need groundwater for farmers to irrigate their crops, for companies who use water in their manufacture of their products, but most importantly for a drinking water supply. And it's a limited source. It's getting harder and harder to find because we have so many people and more pollution problems. So people who specialize in recovering clean groundwater are in very demand in the workplace. And also people who clean up water are underwater water supplies. They're in demand as well. What is an aquifer? Well, I'm not going to play this video for you, but I want you to click on this. It'll help you get ready for the test. But I'll tell you what, in my own words, what an aquifer is. An aquifer is a geologic body that holds groundwater. And it not only does it hold groundwater, but it can hold lots of groundwater, and it's easy to pump out of the ground. When you want to pump water out of the ground, you need a well. So let's take a look. You could buy wells, and you could pump it out of the ground. That's what this farmer here is doing. You have to drill a hole deep into the ground. You have to drill a well deep into the ground and pump it out. Here's an old-fashioned one with a lever on it. But bottom line is, an aquifer is a geologic body that stores large amounts of clean drinking water, clean fresh water, and the water can come out of the ground easy as well. An aquifer has to have high permeability and porosity. Okay, now what is porosity? And what is permeability? Porosity is a measure of the open space in rocks, the air spaces inside the rock. So imagine I had a chunk of rock. If it had a lot of air spaces in the rock, it would have a high porosity. And porosity is a measure of how much water a certain amount of rock can hold. Let me draw you a picture here. So let's say I had a rock. This is a chunk of rock, and there's lots of air bubbles in it. It has a high porosity. If there's the more air bubbles you have in it, the more water you can hold. An aquifer must have high porosity, lots of air bubbles in it. What's permeability then? Permeability is a measure of how well water flows through that rock. And And so let's do another picture here to imagine that. Here's another chunk of rock, and this rock here has a high porosity. It has lots of air bubbles in it. That's what these circles are, air bubbles. But it does not have a high permeability. Why? Because these pores are not connected. However, if you had a rock that had air bubbles in it and the air bubbles are connected to each other, like this, now this rock has high porosity and high permeability. Why? Because the air bubbles are connected. So um, in order to have an aquifer, you have to have high porosity and high permeability. If it's just got high porosity, that's not enough because the water is not going to flow through the rock. An aquifer has high porosity and high permeability. Let's go over some basic terms for when people who study groundwater. The first thing you're going to need to know is what is the water table, also called the groundwater table, also called the GWT. It's this dashed line here on this diagram. That's the water table. Now, beneath the water table, the pores, that's those air spaces in the rock, are filled with water. Above the GWT, above the water table, you're in what we call the unsaturated zone. So beneath the GWT is the saturated zone where the air bubbles are filled with water. And above this dashed line, above the groundwater table, you're in the unsaturated zone where the air bubbles are filled with air. When you sink a well, you need to sink the well underneath the groundwater table, deep into the aquifer, because you're going to start to pump water out of the aquifer. Now, this thing here, they also mention talk about an aquiclude. What is an aquiclude? An aquiclude is the opposite of an aquifer. It is a geologic body that has low porosity and low permeability. In other words, it doesn't hold almost any water and it blocks the movement of water. And so that would be something like a shale. A shale is a good aquiclude. It has low porosity and low permeability. Aquifers, the best aquifers are sandstones. They have high porosity and high permeability. Limestone aquifers are sometimes good too, but usually sandstone's the best aquifer. It's the best place to pump water. Why? It's got high porosity, high permeability. And we already talked earlier on about sand filtering out contaminants. So it removes pollutants too. So we love sandstone aquifers. Here you can see an aquiclude here, probably a shale or something like that with a low porosity and low permeability. And then you have a little perched water table, which is the water table here above this aquiclude produces this little bubble of fresh water. So when you get a perched water table, if there's enough water in the perched water table, you don't have to drill all the way down here into the aquifer. You can drill into here to tap the water, saving you some money. Because for every foot you drill down, it's going to cost you more money. The drill rig uses a diamond edged bit, and there's a whole bunch of guys there who are going to be paid $50, $100 an hour to drill into that rock. So if you have a perched water table, it's going to save you money. Also, since if the water table is intersects with the slope of the land, like it does here, this perched water table intersects with above this river, then you're going to get a spring. And natural spring water is clean, usually. because it's in sandstone, and by the time it gets to the spring and comes out on the slope, it's clean water. That's why they sell it in stores. Natural spring water is clean. So I'm sure you've seen springs before. In Lake City, you can see springs. Not hot. These are hot springs here. I don't know why they don't show normal springs. Let me see. Natural springs. Oh, here's a spring where the water just comes out above a river because the GWT is above, intersects with the slope, and therefore it comes out. So watch that video. That'll help you. Now, the next thing we're going to learn about is an artesian well. What is an artesian well? By the way, when you have a spring on your property, you own the water rights to that spring, meaning you could sell that spring water, or you can sell it to a bottling company, and they will pay you for it. Here's an artesian well. All they did was they sunk a pump into the ground, a pipe into the ground, and the water comes out under its own accord. In other words, you don't need to buy a pump. That saves you a huge amount of money when the water comes out by itself. Why does the water come out by itself? Well, let's take a look and see how an artesian well works. Now, when you have an artesian well, not only do you not have to pay for a pump. That's not a good picture. Not only do you not have to pay for a pump, the water is cleaner. Is cleaner than even spring water. So if you go to places like Whole Foods or Trader Joe's, sometimes they sell artesian well water. Spring water will go for maybe $1.50 to $2 a gallon. Artesian well water will go for $3 a gallon. It's more expensive. Why? Because it's cleaner. Let's take a look at see how we get artesian wells. So you have an artesian well on your property, you're gonna make money because so your real estate's going to be worth more. So that's why it's always good to know about the geology underneath your house, underneath your property. Is there oil there? If there's anticlines, there might be. Is there a dome there? It could be natural gas. You own the oil and water rights to your property. Um, so this shows you a situation where you would have an artesian well. And here's your aquifer, usually sandstone. And then you got see where it says upper and lower confining beds? Those are aquicludes. They block the movement of water. It's like a sandwich with the aquifer in the middle and the aquicludes on top and on the bottom. So if you think about it, if it rains here, it's not going to get into the aquifer because the aquiclude is blocking it. Therefore, the only place where water can enter this aquifer, these dipping beds are exposed up in the mountains. So that's the recharge area for the confined aquifer. Confined because it's confined by these two aquicludes. And so the water can only enter into this aquifer up here in the mountains as these beds dip upwards. It's an interesting situation because what that means is you're going to build up a water pressure in this aquifer. Where's the pressure come from? Well, there's two reasons why there's a built-in pressure in this confined aquifer. And the first is that gravity. Gravity always pushes things down. So just by the water moving down from the recharge area, you're going to have a built-in pressure. but you also have the pressure of this overlying rock pushing down on the aquifer. And enough pressure, if enough pressure is there, you can drill an artesian well. You sink the well in, and the water comes out under its own accord. That's called an artesian well. The best wells are artesian wells because they provide clean water, and it's not expensive to remove to get that water out of the ground. Let's talk about cones of depression. What in God's name is this guy talking about? Cones of depression. Well, it has nothing to do with Wellbutrin or Prozac or. When you drill a well, here's a well, and notice that they drilled this well underneath the GWT, the dash line. But when you start pumping water out of that well, the GWT will make this cone called a cone of depression. Now, the more horsepower you have on your water pump, the bigger this cone of depression is going to be. That's called a cone of depression. Well, that gives you some challenges when you're a homeowner. Let's say this is your house here. You're doing well. You just bought a house. Congratulations. Very good. And here's a fence. And here's your neighbor over here. So this is you and this is your neighbor. And this is the property line. Let's say the GWT is this dashed line here. And you decide you want to drill a well so you could take advantage of you can get free water and get off the grid and maybe reduce mass wasting if you have a slope over here. And so you decide to drill a well. And your contractor tells you you need to drill it down under the GWT. That'll make a cone of depression. And so the water table is going to be lowered here like that. That's your cone of depression. Well, you're okay legally speaking here. But let's say now that your neighbor has drilled his own well over here. And he has a much bigger pump. And so he has a bigger cone of depression. Like that. Okay? Both of you are okay here under what we call American water law. You're both all right here. But here's a situation where you would not be all right. Let's say you drilled a well and you made a huge you put a huge pump on there, and good lord, and then the cone of depression is huge and extends beyond the property line. That's going to be a problem because that's going to lower the amount of water he's going to be able to get out of his well. So bottom line is, under American water law in 47 states in the union, you own the rights to the groundwater. You can do with it as you please, but what you do must not affect your neighbor in a negative way. Otherwise, you're going to have a legal problem. So, in legal terms, what that means is Your cone of depression must not extend beyond this property line. So the contractor should know that, but make sure that you tell him that so you don't get in any trouble from your neighbor. So once again, with this being the GWT, if your cone of depression, after you start pumping, if you're, I hate doing this, then um, if you have a cone of depression that goes beyond the property line, like it does here, see, this cone of depression goes to here, which is beyond that fence, you could have a legal problem if your neighbor finds out about it. Click on this to learn more about the water table. And that was a short video, but you've got enough for this week. I'll get some more videos up for Monday.